Let's start by saying the universe is big. When we look in any direction, the furthest visible regions of the universe are estimated to be around 46 billion light-years away. That's a diameter of 546 sextillion or 54 followed by 22 zeros miles. But this is really just our best guess. Nobody knows exactly how big the universe really is. That is because we can only see as far as light, or more accurately the microwave radiation thrown out from the Big Bang has traveled since the universe began. Since the universe burst into existence an estimated 13.8 billion years ago, it has been expanding outwards ever since. But because we don't know a precise age for the universe either, it makes it tricky to pin down how far it extends beyond the limits of what we can see. In this video we will take a look at the massiveness of the universe and find out how far the various planets or other astronomical bodies in the universe are from our Earth. The universe has always been a subject of fascination and wonder for humans, who have been trying to understand its vastness and complexity for centuries. With advances in technology and scientific knowledge, we have come to realize that the universe is even bigger than we once thought. The observable universe, which is the part of the universe that we can see from Earth, is estimated to be around 93 billion light-years in diameter. This means that the farthest objects we can observe are around 46.5 billion light-years away from us. However, this is just a fraction of the total universe, which is thought to be much larger. One way that scientists estimate the size of the universe is by measuring the cosmic microwave background radiation (CMB), which is the afterglow of the Big Bang. The CMB is a faint radiation that permeates the universe and is thought to be left over from the moment when the universe was just 380,000 years old. By studying the patterns and fluctuations in the CMB, scientists can estimate the size and shape of the universe. Recent measurements of the CMB have suggested that the universe may be even larger than we previously thought. In 2018, a team of astronomers used data from the European Space Agency's Planck satellite to estimate that the universe is around 10% larger than previously thought. This means that the total size of the universe may be closer to 100 billion light-years in diameter. However, the true extent of the universe may be even larger than this. There are still many mysteries surrounding the nature of the universe, including the properties of dark matter and dark energy, which are thought to make up around 95% of the universe's total mass energy. Scientists are still trying to understand these phenomena and their impact on the expansion of the universe. Another intriguing possibility is the existence of multiple universes, known as the multiverse theory. According to this theory, our universe may be just one of many universes, each with its own physical laws and properties. This idea is still highly speculative and has yet to be confirmed by scientific evidence, but it highlights the sheer vastness and complexity of the universe. In addition to its size, the universe is also constantly expanding. In fact, scientists have found evidence that the expansion of the universe is actually accelerating, which suggests that there may be a form of energy or force that is driving this acceleration, called dark energy. The discovery of dark energy has revolutionized our understanding of the universe and raised many new questions about its ultimate fate. Despite our growing knowledge of the universe, there is still much that we do not know. The sheer size and complexity of the universe continue to challenge our understanding and push the boundaries of human knowledge. As we continue to explore and study the universe, we can be sure that there will always be new discoveries and mysteries to uncover. The universe is also expanding, which means that its size is constantly increasing over time. In fact, scientists have found evidence that the expansion of the universe is actually accelerating, which suggests that there may be a form of energy or force that is driving this acceleration, called dark energy. There are also theories that suggest that our universe may be just one of many universes, each with its own physical laws and properties. These ideas are still being explored and studied by scientists, and there is much that we still don't know about the true extent and nature of the universe. So, how big is the universe? But that is merely the visible universe. What about the entire universe? How can we know about parts that are so far away that we have not even seen them yet? That's where things get interesting. It may be surprising, but astronomers are not 100% sure they know the geometry of space. It could be flat, or it could be curved. While space is three-dimensional, we can use a two-dimensional analogy to understand what that means. In 2 dimensions, flat means flat, like the surface of a table. However, a two-dimensional surface could be curved, like the surface of a globe, but it also could be curved like the surface of a saddle. If it's curved like the surface of a globe, that means if you had a super-fast spaceship and traveled long enough, you could end up back where you started, like a plane flying along the Earth's equator. Astronomers have studied the data and have determined that space is flat, or nearly so. However, this determination is a measurement, and measurements have uncertainty. It remains possible that the universe has a very tiny curvature. But if it is curved, then the equivalent of the universe's equator is at least 500 times bigger than the visible universe. Or possibly bigger than that. So, despite not knowing the size of the entire universe, astronomers know that it is at least 500 times larger than what we can see. That number represents the distance one would have to travel to return to your starting location. In the same way that the volume of a cube is the distance along the sides cubed, the volume of the entire universe is, at a minimum, 125 million times bigger than the visible universe. The bottom line is that the visible universe is incredibly large, and the entire universe is truly enormous indeed. The entire universe could be infinitely large. So what do you think about the vastness of the universe, and what did you learn from this video? You can comment below. If you enjoyed, then hit the like button, and if you haven't yet subscribed to our channel, subscribe to it too. Thanks for watching.